So yesterday we had done this part, and we had seen that we had the function itself and the derivative and the integral of the function. And one of the things that was in your packet, it's in your packet on the page before, said that when you have a series, you can differentiate or integrate the series, but it might change the interval of convergence. It wouldn't change the radius, but it could change the interval of convergence. And we had gotten to the point where we were looking at this problem, but then you guys looked dead, and so we stopped. Okay, so what I did is I did these myself, and I just wrote them out, and I can scan them and put them up on the website. Or if we look at them right now and they don't make sense, then we can just go over them together, okay? So what I did is I went ahead and I took the derivative, was this one right here. And so my general term was x to the n minus 1. And I said that the center was 0 and the radius was still 1. And I found that by doing the ratio test. So this is me going through the ratio test. And I found the radius was still 1, just like it was for the other problem. But when I tested the endpoints, I found that both of them diverged. Okay, and that was different because yesterday we did have a radius of 1, but we had -1 converge. Okay, so it's a different conclusion. So when we took the same function, but we took the derivative while the radius stayed the same, the interval of convergence was slightly different. Okay, same thing with the integral. So I had the same center, I had the same radius, I still did the ratio test. When I checked the endpoints on this one, both of the endpoints converged. Okay, so the point of doing these problems was to show you that you can take the integral of a series, you can take the derivative of a series, and your radius will stay the same, but your interval would change a little bit. Okay, but it does tell you that it's definitely an operation you can do, and it's something that is asked of you every so often. It'll be like, I don't quite know what that is, but if I take the derivative, then it becomes what I want. Or I don't quite know what that is, but if I take the integral, then it becomes what I want. That kind of is a clue to how to do some of these problems. Okay, so if you guys want, we can go through the steps of this together, or if you are okay with trusting that it did work out that way, I can scan this, put this on the website, and then you could just print it out and have it. What do you guys want? Go over it, scan it, go over it, go over it? Okay, so if you want to, we are not going to do these 3 examples, so if you guys just want to cross these out, you can show the work down here if you wanted to. Because I think you guys have already done the Maclaurin series where you evaluate it for something else and you just plug that in. So I think these ones are kind of like, you could have done them already. So let's go ahead and just say, I'm going to get rid of those notes right there. So let's go ahead and do the second one. So I'm going to say, yeah, this is for the derivative. So I'm going to call this one number 2. So I'm going to do x to the n minus 1 and I know that my center is still 0 because if I had parentheses with the x, it would have been x minus 0, and that's why there's no parentheses. So I know that's my center is 0, and I'm going to go ahead and do the ratio test. So I'm going to do the limit as n goes to infinity of x to the n plus 1 minus 1 over x to the n minus 1. It was pretty loud. All right. All right, so this is the limit as n goes to infinity. What would the top become? Just x to the n, right? And then the bottom, if I separate those, that'd be x to the n and x to the -1. And what happens with that? These cancel. What do I do with an x to the negative 1 if it's on the bottom? Yeah, you could think of it as 1 over x, or you could just move it to the top, right, and make it positive. So what we have is the limit as n goes to infinity of just x. So in the ratio test, what would make this converge if it was less than 1? Okay, so I'm going to say this equals the absolute value of x, and as long as that is less than 1, then it would converge. Okay, so I'm going to say my radius is 1, and that means my interval, if 0 is the center, my interval is from -1 to +1, and now I go through the process of checking my endpoints. So if I check -1, I'm going to get -1 to the n minus 1. And what type of series is this? You could say alternating. The alternating series test would be inconclusive, though. Why would it be inconclusive?
There's no bottom.
Yeah, there's no bottom. It would have to go to 0, and it wouldn't go to 0. So what's another test we could use on this one? It's a geometric. Do you guys see it? A number to an exponent. It's a geometric. Okay. So what's the r value? -1. Is r allowed to be -1? No. So I'm going to say right here that the absolute value of r is greater than or equal to 1, because that was the rule, right? It had to be less than 1 for it to converge. If it's greater than or equal to 1, then it diverges. So I'm going to say it diverges. I'm going to write up here it was a geometric. Okay. So we know that the -1 is a parenthesis. And then if we check the +1 to the n minus 1, same thing. Yeah, all right, same. Okay, and so parenthesis on both sides. To converge. So I was saying the r was greater than or equal to 1, and that's why it diverges. And so that's why we did a parenthesis, not a bracket. Okay. All right, for the next one, we're going to do the integral, and the integral became x to the n plus 1 on the top, and then n times n plus 1 on the bottom. So again, since that x is all by itself, that's a center of 0. And then we can go ahead and do the ratio test. So I'd have x to the n plus 1 plus 1 over n plus 1 times n plus 1 plus 1. And so I can start to think about what would cancel out. Yeah, so if I think about rewriting that, that's x to the n plus 1 times x to the 1. And so that cancels. Yeah, n plus 1 cancels, yeah. And so the limit, when you plug in the infinities, it's just x. It's going to converge if that's less than 1. So again, we're confirming we got the same radius. So the function, its derivative, and its integral all had a radius of 1. They all had a center of 0, all had a radius of 1. Okay? So now we know our intervals from -1 to 1, but we got to check our ends. So if I check -1, then that would be -1 to the n plus 1 over n times n plus 1. And what test would that be? Yeah, alternating series, AST. And so we'd say the limit as n goes to infinity of 1 over n times n plus 1 is definitely 0, so it hits that condition. And then the second condition is that 1 over n plus 1 times n plus 1 plus 1 is less than 1 over n. And is that true? Mm-hmm. Okay. And so, based on the alternating series test, we're going to conclude that -1 should be included in the interval. And if we check +1, so 1 to the n plus 1 would be what? It's just always 1. So it's kind of like that part didn't even have an exponent there. What does the n times n plus 1 on the bottom make you think of? Yeah, if you multiplied it out, you'd have n squared plus n. So what type of test are we going to do? A comparison with a p-series. Okay? So I'm going to compare this with what? Yeah, 1 over n squared, which is a p-series, where the p equals 2. And so this, we're comparing it with something that converges. Okay. I always forget the direct comparison test. Does anyone know if that would work on this one? The right side converges, so the center converges. Was that it? Okay. I'm trusting you guys because I don't remember. If that's wrong, then I'm gonna have to remake this video. Are you gonna make me remake this video? No, I can trust you.
If the center converges?
If the right side converges, then the center converges?
Yeah, and if the center diverges,
then the right side? Okay. So 1 over n times n plus 1, 1 over n squared. Is that an equal, or is this an equal to? Okay. So this one converges, and so that one converges. And so that means we can go back and make the other one a bracket. I did the limit comparison test when I did it because that's the only one I remember.
So, since both of these values are included, does that mean any values between these two?
Mm-hmm. So if you were to take any number between -1 and +1 and plug it in for x and go back to last unit and ask yourself, does that series converge? Your answer would be yes every time.
So,
Oh yeah, let me.